Okay, I think it's doing its thing now. So the solution is really different, but the methods are the same. And in this particular problem, obviously, I'm going to use substitution. How come? This y equals this. So, but they are the same. So I'm just going to replace it in here. I don't have to do anything else. It's already solved for us. It's a simple example, right? So then x squared plus 4x plus 5 must equal x squared plus 2x minus 1. That is a must. Simple. Subtract 2x, subtract 5, so x is negative 3. And you can say, wait a minute, that's not enough, and I agree. It's not enough. We just found x. Now I have to go back to any of the two equations. It doesn't matter. Let's say I go back to this one. So I have y equals negative 3 squared plus 2 times negative 3 and minus 1. So negative 3 squared is 9. This is negative 6 and minus 1. So this happens to be 2. I claim negative 3, comma 2. I don't know. I have to go back and convince you. I haven't convinced you yet. So I go back to the system and replace negative 3, negative 3, negative 3, and 2. 9 minus 12. 9 minus 12 is negative 3 plus 5 is 2. Yes. 9 minus 6 is 3 minus 1 is 2. Yes. And I will say absolutely yes, I checked. And no one needs to tell me whether it's true or false. So this was substitution. Let's look at
so is that just where they meet, right?
Exactly. But these two are two parabolas.
Right.
These two are two parabolas if you want to graph them. We don't have to, but since you asked, now I have to. So x squared and plus 4x and plus 5, that's the first parabola. And here's the second one, x squared and plus 2x and then minus 1. And I better see this, but I'm going to use the standard viewing window. And they will intersect exactly where we wanted them to intersect, at negative 3, comma 2. And that's it. That's the point. Negative 3, comma 2. That's the only point of intersection. Thank you for asking. Perfect. Okay, so now let's look at 26 caught my eye on page 587. I did write the page there, yes I did. Okay, so we have x squared plus y squared equals 5. And we have x squared plus y minus 8, everything squared equals 41. Okay, so I'm looking at these two equations. I see they are nonlinear. They have power 2. Power 2 is not linear. And I'm asking myself, can I eliminate y? Absolutely not. Because I don't have, here I have y squared, but yeah, here I have completely something else, completely different than that. So I can't. Can I use substitution? Yes, I can. I can solve for x squared and plug it in here. It's up to you. Or I can use elimination, multiplying the first, both sides by negative 1 to eliminate this, because I cannot eliminate y squared. So when I multiply by negative 1, I get negative x squared minus y squared equals negative 5. I keep them together, x squared plus y minus 8 squared equals 41. And now when I add, I have to be very careful because I cannot add these. I just have to write them the way they are. I have to write y minus 8 everything squared minus y squared, and 41 minus 5 is 36. What type of equation is this, and how many solutions do we expect to get? Excellent, because it's a quadratic equation. Awesome. And now the next step. What should I do next to solve this? This is from our past, and we know everything about this. Ready? What would you do? And then I'll tell you what lazy people like to do. Yes, we have to expand this. And how many terms do we get? This was our first encounter this semester. The first time we met, we discussed this.
Factor it?
No, it's already factored. We have to expand it. How many terms will this have? Please make me proud. Please.
2.
Let me refresh Kayla's memory, please. I have to do it. A squared minus 2ab plus b squared. 3 terms. Yes?
Yeah, sorry.
No, that's okay. Okay, so then, but lazy people, I shouldn't say that, but people who don't want to square this, they will use the difference of squares, which is much easier, but that's okay. Let's square. So the first term squared, minus 2 times the first times the second, minus 16y, plus 64 minus y squared equals 36. So I use this formula again, y squared minus 2 times the first times the second. 2 times 8 times y is this, plus the second term squared and minus y squared. These two go away. Then negative 16y, and I move 64. And 36 minus 64, I think, is negative 18. Is it? 64 and 36. Yes. 3 from 5 is 28, sorry. Okay, so then y equals 28 over 16. Is everything okay so far? Yes? Any questions? Any questions, anyone? I'm checking my numbers, of course. It was negative 16. So 64, 8, 3 from 5 is 2. Yes. And 28 over 16. And I simplify by 4. And I get 7 divided by 4. Okay. So now I have to go back with y, which is 7/4, anywhere. Because I'm not done till I find x. So I'm going to plug it in here. So I have x squared plus, I have to square y, which is 49 over 16, equals 5. We can always go back and check, and we'll know exactly whether we have an error or not. So this is x squared, which is 5 minus 49 over 16. And we need to multiply by 16. Remember, we have to find the least common denominator. So let's see what do I get. 16 times 5 and minus 49. 31 over 16. Okay. Now, this is another method that we have to apply here for solving quadratic equations, and we talked about it, and we talked about it, and we talked about it. what do we need to apply here?
Square root.
Thank you very much. How many solutions?
2.
Thank you very much. The square root of 31 divided by 4. So we claim 2 solutions here, both with 7/4 sy, but x could be the square root of 31 over 4, and the negative the square root of 31 over 4. And now you should say, I don't trust this. Actually, I don't either, if you say that. And I will check it. I will plug the solutions in here to make sure that I get 5 and 41. I don't trust it either. So when I square this, I get 31 over 16, plus when I square this, I get 49 over 16. And let's see if we get 5. So 780 divided by 16, and this is 5. 5 times 6, 0, and 3. Yes, this is correct. Now I have to check the second one. So I square, and it doesn't matter because they're squared, right? So it doesn't matter if I check this one or this one, because I don't have it x. I only have x squared, so it doesn't matter which one I check. So still 31 over 16 plus 7 over 4 minus 8 squared. Does this, we don't know yet, does this equal 41? I have no clue. I have to check. Okay, 31 over 16 plus, the least common denominator is 4, and 7 minus 32. And what do I get? I get 31 over 16 plus something over 16, and 7 minus 32 is 25. And 25 squared, positive or negative, it doesn't matter, is 625. And 625 plus 31 and divided by 16, luckily, is 41. So now I will say yes, and yes, I checked. This is it. It's the correct solution. Any questions? Any questions?
Will there always be two different x's, or can there be 2 different y's?
They can be 2 different. They can even be 4 solutions. Let's take a look at another example. Very good question. We can conclude. Very good question. Excellent. So let me go back. I think I took this out of my trash, my recycle bin, like 5 times already. Here is the only time in which we can say, I know what to expect. But they have to be 2 linear equations. If they're not linear, we can no longer put them in 3 different categories. We can have anything. We have no idea. So the easiest ones are linear equations, linear systems. But when it comes to nonlinear, we have no clue. We don't have categories. We can't think. We have to just act. Okay, let's look at 37 on 588. That's why I did not put them in any category. Thank you. Very good question, Vinny. Thank you. So 38, sorry. No, 37. Sorry. X squared plus y minus 2, only because it's kind of similar. X squared minus 2y equals 0, because I want to answer Venus' question. Okay. So the same idea. I want to multiply the second equation by -1 to eliminate x squared. I cannot eliminate y. This is y minus 2 squared, and this is not even squared. So the only variable that I can eliminate is this one, because they are the same, right? Same and variable in both equations. So I copy x squared plus y minus 2 squared equals 4. And I copy the second one as negative x squared and plus 2y, and 0 times -1 is 0. Yes, I add. These two go away. I copy y minus 2 squared. I copy plus 2y. And on the other side, I have 4 plus 0, which is 4. Is this okay so far? Yes, like I did before, I have to expand this. The first term squared minus 4, in other words, 2 times the first times the second, minus 4y, and plus 4 plus 2y minus 4 equals 0. I have to get it ready. So then y squared, and this is minus 2y, and this is nothing. I love it when I don't have the free term, because I know there are only two options, 0 and 2. So that's good, but I have to go back and determine x. So when I plug in 0 here, I get two solutions, but they're both 0. So for this, there is only one option. But now when I plug in 2 here, I get x squared minus 4 equals 0, which we know it will have two solutions, x equals plus or minus 2. So now here we have two options, x to be 2 or x to be negative 2. So all of a sudden we found a system with three solutions. So 0, 0 is one, 2, comma 2 is the other, and negative 2, comma 2 is the third one. Any questions?
Can you have like a linear and a quadratic?
Yes, let's go. Let's look for that. Perfect example. Let's look at 42. X minus 3y equals negative 5. I'm sorry, I forgot to ask. Anyone has questions about this? Is this okay, everyone? Okay. So we have x minus 3y equals negative 5 and x squared plus y squared, minus 25 equals 0. Now this system is still considered nonlinear because it has a nonlinear equation. Even if this one is linear, the entire system has to be considered nonlinear. Okay, so in this particular case, there is nothing I can do to eliminate. Nothing. I cannot eliminate this because they're not the same variable. I cannot eliminate these because they're not the same variable. My only chance is to solve for x because it has 1 as the coefficient. So x equals 3y minus 5. And replace x and square it in the second equation. When I use substitution, I don't have to keep them together. So I have 3y minus 5, everything squared, plus y squared minus 25 equals 0. Of course, I have to expand this. I get three terms. The first term squared, 9y squared minus 2. Of course, I will multiply 2 by 5 first because it's 10, 30. Plus the second term squared, plus y squared minus 25 equals 0. I love it. 9y squared plus 1y squared is 10y squared minus 30y equals 0. Of course, I will divide by 10 to simplify my life. So I have y squared minus 3y equals 0. Nobody cares. It's not going to change the solutions. And this is the easiest type of equation, quadratic equation, that you can ever have. The one without a free term. You don't have to think of a formula. You just have to pull out the y and you're done. Okay, now we have to write the solutions, right? So we found y to be 0. I have to plug it in here and get x equals negative 5 then. Then I have to plug in here. 3 times 3 is 9, minus 5 is 4. So then the solutions are 4, 3, and negative 5 comma 0. You should always go back and check, always, so you don't miss any points.